Hi. I don't know where you are coming into this video, whether you're at home using your laptop or you're in one of the computer rooms at the ETSU. But wherever you are, this video is designed to talk about word problems or challenge problems. Remember, we started talking about word problems or challenge problems out of Chapter 4 in our last class meeting. And I thought that it might be good if we looked at some word problems, did some word problems so that you would have a video that you could turn to as we continue our study in Chapter 4 on word problems. I'm going to take you back to a diagram, the one that's here on the screen, that sort of illustrated in picture form the kinds of things that you need to be interested in or concerned about when we're looking at word problems. Remember, word problems more often than not will come to us in printed form. But remember, kids during kindergarten, first grade, even second grade, they're learning how to read. And so some of the word problems that you present to them, you may present to them orally, and they'll just listen and try and take the information that you've shared with them verbally and transfer that into an environment of manipulatives or to pictures on a piece of paper. So looking at the screen in front of us, which is entitled Picture Diagram to Illustrate Solution Path for Challenge Problems, we're going to look at it as we've already done. You're going to be looking at a word problem or a challenge problem, as I like to call them. The question is when you start reading the words in the word problem or the challenge problem, how many times do you have to read it to try and figure out what the problem is saying, what's involved in this problem, what questions it's asking you to answer? And in class I said, well, how many times will you have to read the word problem? Well, the answer is as many times as it takes for you to take all the information that's in printed form and transfer it to picture form on a sheet of paper. So you'll read and you'll read and you'll read till as many times as you're able to do that. So looking at this picture, mapping frames is just a fancy name for how you're going to describe the information that's in printed form in picture form. So a mapping frame may be any one of these types listed here on this document, 10 frames, 20 frames, which kids become familiar with in kindergarten or first grade, pictures, diagrams, T-frames, horizontal strips, vertical strips. In fact, any kind of picture that represents or describes the words that you are trying to represent from the word problem, those constitute mapping frames. Now, once you start putting your mapping frames on a sheet of paper to help give you a picture or a visual of the information that's in printed form, your mapping frames are going to change. Your first picture won't necessarily be your last picture. It'll be a start, just like we talked about in class when we were talking about stacking textbooks into 3 stacks on a floor. The first sentence says there are 3 stacks of textbooks on the floor. Well, your first picture is going to be possibly, 3 little rectangles sitting vertically to represent the 3 stacks. But the second sentence said that the second stack had twice as many books as the first stack. That will require that you go and modify your original picture and change it so it reflects the new information as you're reading it. So again, mapping frame is any picture that represents the information that's in printed form, and it will become adjusted or modified as you continue to read more information from the picture. Now, during the time in which you are drawing your mapping frames, you are illustrating relationships between quantities and sizes of groups, and along the way you're trying to figure out, well, what is this problem wanting me to answer? What's the question here? What's the target set? Remember, the target set's the set that you want to find the size of. So you're going to locate the target set from your mapping frame, and once you get your target set, you want to determine its size. And so the size of the target set may result from putting groups together, addition, taking a group and removing some, subtraction. You have several groups, they're all of the same size, multiplication, and so on. So you have to figure out the arithmetic expressions involved necessary to find the size of the target set. And then once you determine the target set and the arithmetic expressions involved, you're going to have to figure out a computational strategy that will help you determine the size of your target set. And remember, we talked about these in Chapter 3 and Chapter 5, computational strategies for determining target sets that come from addition, multiplication, subtraction, or division. Now, once you get the size of the target set, you want to ask yourself, well, how does this answer the problem that I'm trying to solve? So you want to ask yourself, is your answer reasonable? which is the size of your target set. Is that answer reasonable? Does it make sense? Does it satisfy the problem conditions or constraints? Did you verify the arithmetic along the way? Finally, once you've decided that you've got an answer that you believe solves the problem or answers the question that's being asked by the word problem, you want to write your answer to the problem in a complete sentence form, properly punctuated, first word capitalized, a period at the end of the sentence. When you do this and you ask your kids to do this, they're letting you know by what they write down that they really understand the problem and they know how their answer actually answers the problem that they're actually trying to solve or the question they're trying to answer. So we looked at this particular picture form of solving challenge problems in class. What I want to turn to now is I want to turn to some problems and go through some problems to, again, illustrate some of the things that are involved in solving a word problem. This, I believe, is a document that's attached to our supplement of Day 19, Agenda for Day 19. It's on the D2L site, and so we're going to look at these problems together and illustrate how the steps we would go through to solve a word problem or a challenge problem. So let's look at this first problem that involves a young lady named Lindsay. And so as I read, you read along with me. It says, Lindsay has 95 lemons to sell. She puts 8 lemons into a bag and sells the bag for $4. How many bags of lemons can Lindsay sell? And we're assuming that she is only going to sell bags that have 8 lemons in it. And since she's selling them for $4 each, how much money does Lindsay make by selling her lemons? So what we want to do is take this information and we'll read it. You may have to read it a second and a third time. I think I've got this information in my mind now. 95 lemons, 8 lemons to each bag, and she's going to get $4 for that. And so I'm going to minimize this screen and start looking at this problem. Let's bring up a whiteboard. Now we're starting out with 95 lemons. So I'm going to write the 95 lemons here. And what Lindsay wants to do is she wants to start pulling the lemons out 8 at a time and creating a bag of lemons. So I'm going to put 8 lemons here, and I'm going to do it abstractly. And so we've removed 8 lemons from the 95 lemons. Then we're going to do it a second time. Here's a situation where we have 95 lemons, and we're starting to distribute these lemons into bags that are of size 8. So the question is, well, how many bags of size 8 can we get from the 95 lemons? Well, you should know that this is a partitive or quotative division problem. This is a quotative division problem because why? I know the size of the bags. It's 8 lemons per bag, and what I want to know is continue this process. How many bags of 8 lemons can I get? So it's a division problem. So I'll formally write out here, I have 95 lemons. That's my dividend. I'm dividing it into bags of size 8. So 8's my divisor. And I want to know how many bags that I can get from these 95 lemons. So the question is how many bags? So I'm going to come over here to the division problem, 95 divided by 8, and I'm going to use one of our division strategies. Now, since the divisor is only single digit, what I think I'm going to do is decompose the dividend into chunks that I know are easily divisible by 8. One chunk is 80. Then I know once I take 80 from 95, I've got 15 more to distribute. And of the 15, I can write it as 8 plus 7. And now I want to divide that by 8. And so I'm going to divide 80 by 8, and I know that that's 10. I'm going to take the 8, divide it by 8. I'll know that that's 1. And then I've got 7 lemons, and so I cannot make up a bag of lemons that has 8 lemons in it with 7 lemons. So I've essentially got 7 lemons that I'm going to put off to the side, but I do know that I can make 11 bags of lemons that have 8 lemons in each bag. So how many bags can I form? 11 bags. And I answered it using a computational strategy where I decomposed the dividend. So I've got 11 bags. Now remember, each bag was sold for $4. And so if I take the 11 bags and I know I'm going to sell them for $4 each, then it's just a multiplication problem where there are 11 bags and the cost for each bag is $4, and I'll do the calculation. At this point, they might know that 11 times 4 is $44, or they may have to use a backup plan to figure out what 11 times 4 is. Let's just accept the fact that we can figure out that it's $44. So we know the answer to our problem is that Lindsay, using the 95 lemons, can form 11 bags of lemons with 8 lemons per bag. And if she's going to sell them for $4 each, she could make $44. Now we want to answer the question in a complete sentence. So we could say Lindsay can sell 11 bags and make a total of $44. There's your complete sentence. First word starts with a capitalized word, and I put a period at the end. And so here is the answer to this problem written as a complete sentence. So there's our first problem. Let's go back and look at, now I'm going to start a new page. Go back and look and see what the second problem is. Second problem is a baker needs 5 eggs to bake a cake. I don't know whether that's a lot of eggs or a few number of eggs. I'm not much of a cake baker, but a baker needs 5 eggs to bake a cake. She has 4 dozen eggs. And if you remember, there are 12 eggs in a dozen. She has 4 dozen eggs. First question is how many cakes can she bake by using all the eggs? B, how many eggs are left after baking the cakes? Okay, so we're starting out with a problem where we know that every group of 5 eggs bakes a cake. We know we're starting out with 4 dozen eggs, and we want to find out how many cakes, whole cakes, we can bake by using these eggs. So let's go back to our smartboard. So we're starting out with the fact that 5 eggs give rise to 1 cake. But we know we're starting out with 4 dozen eggs. So we're starting out with 4 dozen eggs. And we want to figure out how many cakes can we make with the 4 dozen eggs. Well, from the 4 dozen eggs, since I know that there's 12 eggs per dozen, I want to go ahead and figure out what's the total number of eggs here. So I know that there are 4 times 12, which equals 48 eggs. So I've changed the 4 dozen to 48 eggs, and the 48 eggs are what I'm going to use to start baking cakes. So I know that it takes 5 eggs to bake a cake. So I'm going to take out 5 eggs. And that gives rise to a cake. Then I'm going to take out another 5 eggs. It gives rise to another cake. And then using this mapping frame, or this picture of the situation that's described by the second word problem, I've got 48 eggs. I want to start separating those out at 5 at a time. And I know if I do this twice, I've removed 10 eggs total from the 48, so I know I have 38 eggs left. But I don't want to do this 5 eggs at a time by repeated subtraction. I'm going to go ahead and speed up the process, and I want to know, when I get finished, how many times can I remove or take away 5 eggs from the 48? Well, it's a division problem, so I have 48 eggs, and I'm going to divide them by specifying the size, very much like we did with the problem with Lindsay, the first problem. So I'm dividing it by 5 eggs, and I want to know how many times I can do this. So unit of measure, eggs, unit of measure, eggs. So dividend and divisor have the same kinds of unit of measure. So we know it's a quotative division problem. So it's quotative division. I'm going to head and take the 48, and I'm going to separate it into chunks that I can easily divide by 5. Now, you or your kids separate the 48 into chunks that are easily divisible by 5. It's a personal thing. Remember, you and your kids are in charge of the numbers, your boss. I would probably separate it into 40 plus 5 plus 3. Some of your kids may separate it into 20 plus 20 plus 5 plus 3. And there's several other ways they can do it. But if they separate the dividend or decompose the dividend into 40, a 5, and a 3, they know that 5 goes into 40 8 times, and 5 goes into 1 time. And out of the 3 remaining eggs, I cannot bake a whole cake. So those 3 eggs will be sort of set off to the side. So the quotient ends up being 9. In other words, I can divide 5 into 48 9 times, and I've got a remainder of 3 eggs. And I'm not going to use those to bake a cake. So now I know, since I can get 9 groups of eggs, that means over here, in figuring out how many cakes I have, it turns out that I can get 9 cakes to bake. I can bake 9 cakes, and there are 3 eggs left over. So I want to go ahead and write down the solution to this particular problem and write it in a complete sentence form. So I'm going to do that right here. So the baker can bake 9 cakes from the 48 eggs, and there are, how many eggs left? There are 3 eggs left or left over. So there's our answer to the problem, written in a complete sentence form. First word, the, capitalized, period at the end of the sentence. The baker can bake 9 cakes from the 48 eggs, and there are 3 eggs left over. So let's turn back to our list of problems. I'm going to go to a new page here for the next one. So going to my list of problems, I want to look at the third problem that involves pirate ships. There are 3 pirate ships named Zor, Thor, and War. On the first ship, Zor, there are 78 pirates. On Thor, which is the second ship, there are 49 pirates. And on War, the third ship, there are 63 pirates. How many more pirates are there on the 2 ships, Thor and War, which are the second 2 ships, together than there are on the first ship, Zor? So let's read through it again. There are 3 pirate ships named Zor, Thor, and War. So let me go ahead and do that. And I've got 78 on the first, 49 on the second, and 63 on the third. So I have a pirate ship. I know it doesn't look like a pirate ship, but it's close. Okay, so I have the 3 pirate ships. I think the first one is Zor, second one is Thor, and the third one was War. And on the first pirate ship, let me go back and look, there were 78 pirates, 49 on the second, and 63 on the third. So 78, 49, and 63. 78, 49, and 63. And I want to know something about these 3 ships. The pirates on the first ship, there's 78 of them. The pirates on the second ship, Thor, there are 49 of them. Pirates on the third ship, War, there are 63 of them. So what's being asked? There are 3 pirate ships named Zor, Thor, and War. On Zor, there are 78. On Thor, there are 49. On War, and 63. So I have those numbers correct. Now, how many more pirates are there on the 2 ships, Thor and War, which I believe are the second and third ships, together than there are on the first ship, Zor? So it looks like a comparison problem. So let's turn back to our whiteboard again. So we're wanting to take these 2 ships, which are the last 2 ships, and I want to combine them. So I want to take the 49, combine it with the 63, and I want to find out how many pirates are on the second and third ship together. When I get finished, I want to compare that number of pirates to the number of pirates on the first ship, Zor, and I want to see how many more pirates are on the second, third ship than there are on the first ship. So first task, it looks like we need to add these together, 49 and 63. And there are different ways to do that. I could, take 1 from the 63 and make this 50 plus 62, since I borrowed 1 to put over with the 49 to make it friendly. Then of the 62, I can separate the 62 into 50 plus 12. And I can say, okay, I could add the 49 and the 63 together this way, and I come up with 112 pirates. Or I could take the 49 plus 63, and I could add the 40 and the 60 together, which is 100. I could add the 9 and the 3 together, which is 12. So I'm adding 100 to 12, so that's 112. So there's a second way to find the total number of pirates on the second and third ship. And there's several other ways. Again, I'm just illustrating how to approach a word problem. So we've been drawing pictures called mapping frames or mapping devices to sort of get some information about the nature of the problem and what it is that we want to find. Now, once we know that there are 112 pirates together on the second and third ship, Thor and War, I want to compare that to the 78 that are on Zor. So these 2 together, Thor plus War, we know that there are 112 pirates. And what we want to do is compare it to the number of pirates that on Zor, and there are less pirates on Zor, namely 78, than on the 2 ships, Thor and War together. So I want to know how many more pirates there are on the 2 ships, Thor and War together, than there are on the ship Zor. So it looks like it's a comparison problem, and remember, we can transform a comparison problem into a subtraction problem because we could remove 78 from the 112 and see what's left to see how many are more. How many more pirates are on the Thor and War ships than on Zor? So I'm going to think of it as a subtraction problem because it's really a comparison problem, but I can use subtraction to answer the question to a comparison problem. So now how am I going to perform this subtraction? Well, again, I could use shifting and take the subtrahend and make it into a nice friendly number. One is I could add 2 to get to 80 and 20 more to get to 100, so I could write this as plus 22. Then I'd have to add 22 to this one, and that's 134. And so finding 112 minus 78 is the same as finding 134 minus 100, which turns out to be 34. And there I used shifting to accomplish that, or I could take the menu in and split it into 99 plus 13 and subtract 78. And the reason I split the 112 into 99 plus 13 is it's easy to subtract the 78 from the 99. And so I'm going to look at 99 minus 78 and then put the 13 back in when I get finished. And when I do that, 99 minus 78 is 21. Then I've got to add the 13 back to it. And so when I add the 21 to the 13, sure enough, it's 34. So I know there's 34 more pirates on the two ships Thor and War together than there are on the pirate ship Zor. So I'm going to say that in sentence form. There are 34 more pirates on the ships Thor and War than on the one ship Zor. So again, I've answered the question in such a way that whoever is reading this problem can understand that the person who solved this problem, it made sense to them and they understand what their solution represents. So again, make sure that your solution to your problem is written in complete sentence form. So let me look for a new picture and another word problem. So now we're looking at problem 4, and this involves three sisters. It said 3 sisters, Jessie, Sammy, and Patty, weighed themselves. And you know, women don't like to weigh themselves. Worse, they don't like to share that information with others. But in any case, Jessie, Sammy, and Patty are 3 sisters. They ended up weighing themselves, and now we have some additional information about their weights, the relationship of their weights together. So in our picture, we have Jessie, Sammy, and Patty. So we have Sammy, Jessie, and Patty, and they weigh themselves. Now I'm drawing a picture because I haven't read further to find out what the relationships are on these weights. I'm just writing down the fact that I've got 3 sisters and I'm using the initials S, J, and P to represent the names of the sisters. And I've got little strips to represent their weights. Let's go back to the problem and see how further reading might modify these strips. Jessie, Sammy, and Patty weighed themselves. Now, I think I ordered these differently because I think I put Sammy in first position, and that's okay. Go ahead and think about that. So in this information, it says that Jessie weighed twice as much as Sammy. Jessie weighed twice as much as Sammy. So Jessie weighed twice as much as Sammy. So now I'm going to draw a new picture. Here's Sammy's weight and Jessie's weight. I want to illustrate with a strip that it's twice as much as Sammy's. Let me go back and make sure we've read that problem correctly. So Jessie weighed twice as much as Sammy. And then Patty weighed 3 times as much as Sammy. Patty weighed 3 times as much as Sammy. So here we have, I've got to try and figure out a way to make it 3 times as long. So Patty, third sister, weighed 3 times as much as Sammy. Jessie weighed twice as much as Sammy. So now I have a picture that gives me a relationship between the weights of all 3 sisters. Let me go back and make sure we read the problem correctly. So the 3 sisters, Jessie, Sammy, and Patty, weighed themselves. Jessie weighed twice as much as Sammy. I put Sammy in first position. So Jessie weighing twice as much as Sammy, who's in second position, that should be a strip that's twice as long. Patty weighed 3 times as much as Sammy, and so that strip should be 3 times the length of whatever Sammy's strip is. And then finally I have some information that altogether the sisters weigh 438 pounds or 438 pounds. So the weights of all 3 sisters is 438 pounds. In my picture, I see that I split up the weights so that I accurately reflect the fact that Jessie weighs twice as much as Sammy and Patty weighs 3 times as much as Sammy. But these compartments, I don't know how much they are. They're question marks. But the question mark, whatever that weight is, it's the same. So if this question mark, Sammy's weight was 50 pounds, then Jessie, who weighs twice as much as Sammy, she would weigh 100 pounds. And if Patty weighs 3 times as much as Sammy, who weighed 50 pounds, she would weigh 150 pounds. But I don't know what that weight is. I just know the relationship. So I know that in these compartments there are, starting with Sammy, 1. Jessie has 2 of them that are the same size, so that's 3 more. Patty has 3 that are the same size, so I have 6 question marks, or 6 times question mark, must give me the weights of all the sisters. And the weight is 438 438. So I have an arithmetic expression here. Because of the information I learned about the relationship between the weights of the three sisters, and I've drawn my picture, my mapping frame, I know that all those question marks being the same size and being 6 in number, they've got to add up to 438 pounds. So I know that 6 times question mark is 438. Well, remember, there's a relationship between multiplication and division. So in this problem, if I take 438, if I were to divide it by 6, that will tell me what the question mark is. Because remember, in this particular problem, the dividend divided by the divisor has got to be the question mark. Then remember that the divisor times the question mark better get you back to the original dividend, which is 438 pounds in this case for the three sisters. So I've got to go ahead and perform this division. And once again, I'm going to take the 438, and since I'm going to divide it by 6, I'm going to partition the dividend, 438, into numbers, into portions that I can easily divide by 60. So what I might do is I take 300 off, because I know I can divide 6 into 30 or 300. That leaves me 138 left. Again, I'm doing this, so I'm choosing numbers that I'm comfortable with. I see that 300 plus 120 is 420, and that leaves me with 18, so I've got another chunk that's 18, and it just so happens 18 is divisible by 6. So in this problem, I'm not going to have any extra portions or a remainder of any kind. So I've split 438 into 300 plus 120 plus 18, and so I'll go through and divide 6 into each one of these. So I need to find out what 300 divided by 6 is. Then I need to add that to 120 divided by 6. Then I need to add that to 18 divided by 6. And when I get finished, that will tell me the size of the question mark, essentially how much Sammy weighs. So when I go through here, 6 goes into 300 what? Goes into 35, so this is 50. Check. 6 times 50 is 300. 2 50s is 100, and there are 6 of them, so that's 300. Plus, 6 goes into 120 20 times. Double checking, 6 times 20 is 120. Plus, and 6 goes into 18 3 times. So I know that the box or the question mark is equal to 50 plus 20, which is 70 plus 3, so that's 73. So I know that Sammy weighs 73 pounds. So I know that Sammy weighs 73 pounds. Jessie weighs twice as much as Sammy, so she'll weigh 2 times 73 pounds. And Patty weighs 3 times as much as Sammy, so she'll weigh 3 times that. So if we go in and we write this out, 2 times 73 is 2 70s, which is 140 plus 6, so it's 146. And 3 times 73 is 3 times 70, which is 210, plus 9, so it's 219. And so I know that the weights of the three sisters are 73 pounds, 146 pounds, and 219 pounds. So I need to write that. So Sammy weighs 73 pounds, comma, Jessie weighs, since she weighs twice as much, weighs 146 pounds. And finally, Patty, who's the heaviest of the three sisters, Patty weighs 3 times the weight of Sammy, so it's 3 times 73, or 210 plus 9, 219 weighs 219 pounds. So the complete sentence tells the reader in this particular problem that Sammy weighs 73 pounds, Jessie weighs 146 pounds, and finally Patty weighs 219 pounds. And this is a similar one that we at least talked briefly about in class. It says there are 3 stacks of textbooks on the floor. So there's 3 stacks of textbooks on the floor. Now, I haven't read any further, so I don't know what their relationship is other than this is 3 stacks of textbooks. And we're assuming they're all of the same class and therefore all of the same size, but we're actually looking at the number. Now, what's the next piece of information? There are 3 stacks of textbooks on the floor. The first stack has twice as many books as the second stack. The first stack has twice as many books as the second stack. So I'm going to draw this first stack so that it looks twice as high as the second stack, therefore giving me a picture that the first stack has twice as many books as the second stack. First stack has twice as many books as the second stack. The third stack of books has 1/2 as many books as the second stack. The third stack of books has 1/2 as many books as the second stack. Now remember, the second stack, the first stack is twice as high as the second stack. The third stack of books has 1/2 as many as the second stack. So the third stack has half as many books as the second stack, and I'm going to draw a little dotted line here to make sure that we see that the third stack of books, the stack on your far right, has half as many books as the second stack, while the first stack has twice as many books as the second stack. And now I have a relationship of the stacks of books. I'm going to go ahead and draw a line, a dotted line here and a dotted line up here, because I know that this third stack is half of the second stack, so I know the third stack is the same size as each of those 4 compartments in the first stack. And so what I want to know, since these are all the same size, I'm going to use a question mark here, question mark here, question mark here, question mark here, 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 and here. And if I turn back to the problem, what does it say? If there are 315 books altogether in the 3 stacks of books, how many books are there in each stack? This is a little bit like the problem 4 that we just got through looking at. So I know that these 3 stacks of books altogether have how many? 315. I know there's 315 books altogether. Now what I don't know is I don't know how many books are in the third stack. If I knew how many books were in the third stack, I would know how many books are in the first and second stack because of the relationship illustrated by our mapping frame, what their relationship is to the third stack. For example, if there were 100 books in the third stack, there would be 200 books in the second stack, and there'd be 400 books in the first stack, making a total of, 700 books. But we don't have 700 books. We only have 315 books. So I know that those compartments, there are 7 of them that are the same size, 4 from the first stack, 2 from the second stack, and 1 from the third stack. So I know that 7 times the value of the question mark better give me the total number of books, 315. So just as we did in that earlier problem just before this one, I know that 7 times question mark is 315. So I know that 315 divided by 7 is the size of that question mark. And so I'm after the size of that question mark because once I know how many books are in the third stack, I can figure out how many books are in the first stack and the second stack. So I have to do this problem. Probably going to, once again, take 350 and divide it into things that are easily divisible by 7. Now again, how your kids break up the 315 depends on what their number sense is. How comfortable they are with things that are divisible by 7. Some might first start off with 280. Some might go down and say, I want to work with 210. Some might want to go down and say, I want to work with 140. But they're going to pick numbers that are divisible by 7, and they want to start off with as big a number as they're comfortable with. I'm going to start with 280. So if I take 280 away from 315, if I count up, that's 20 to get to 300, and 15 more, that's 35. And both of those numbers, 280 and 35, are easily divisible by 7. If I used 210, it would split up a different way. If I used 140, it would split up a different way. But this one says that when I divide by 7, I get 280 divided by 7 plus 35 divided by 7. And so that gives me what? 7 into 280 is 40, and 7 into 35 is 5. So I know that there are 45 books in that third stack. So I know up here in our picture, I know that there are 45 books there. If there's 45 books in the third stack, then since the second stack is twice as big as the third stack, or the third stack was half the size of the second stack, I know there are 90 books here. And the first stack is twice that, so I know 2 times 90 is 180. Now, I believe the answer is there's 180 books in the first stack, 90 books in the second stack, 45 books in the third stack. I could double check and make sure that 180 plus 90 plus 45 gives me, I don't know that, I'm going to put a question mark, gives me the 315 total books. But if you go through and do the arithmetic, here's 180, take 20 from the 90, that makes it 200, that's 270. Take 30 from the 400, that's 300, and 15 more is 315, that's correct. So I need someone here to write down what it is we discovered. First stack of textbooks has 180 books. The second stack of textbooks, I'm going to write TB, okay, of textbooks has 90 books in it, and the third stack of textbooks has 45 books. finished with a period. So we've answered this particular question by going through some steps that are the kinds of steps that you would follow when you're solving a challenge problem or word problem. Remember, in each of these problems, our first step was to transfer the information in printed form into picture form, or what we might call mapping frames. And that is perhaps the most critical part in solving word problems or challenge problems, is to draw those pictures. And so you want to get your kids in the habit of drawing pictures, transferring the information in printed form, or if you give it to them orally, in printed form into pictures that represents the information that you get from the word problem. So that brings us to problem 6. There are two sisters involved, Juanita and Marie. They go on a shopping spree. They both have the same amount of money at the beginning. However, Juanita spends only $59 while Marie spends $153. And that's usually true about two people. One's a little bit more conservative than the other. So what do we have so far? We have two sisters, Juanita and Marie. They go on a shopping spree. They both have the same amount of money. So how might that picture? So Juanita, I'll use a J, and Marie, they start out and they have the same amount of money. So I'm going to use a strip that's the same length to indicate the money to start shopping spree. So money to start shopping spree, and they're the same length, so they have the same amount of money. Juanita and Marie have the same amount of money. So what else do we glean from this? They both have the same amount of money at the beginning, but Juanita spends $59 while Marie spends $153 or $153. Juanita spends the lesser of the two, $59 and $153. And Marie spends $153. Let me double check those numbers. I'll look back at my word problem again. Juanita spends $59 while Marie spends $153. If Juanita had 3 times as much money left from the shopping trip as Marie, how much money did each sister have at the beginning of the trip? See, what does that say? If Juanita had 3 times as much money left from the shopping trip as Marie, how much money did each sister have at the beginning? So let's go back and look at our picture. So Juanita has a less amount of money that she spent. So that means she has more left. So my picture right now reveals that Juanita spent less, Marie spent more, and so the amount of money that Juanita has at the end of the shopping spree should be a bigger portion of the horizontal strip, and Marie, since she spent more, her little strip should be smaller. But now there's some additional information given. There's a relationship between this amount of money that's left with those two sisters. Now, what is that relationship? So let me redraw the picture to indicate what that relationship is. So if I go back and look at the picture, or look at the words from the challenge problem, it says that Juanita, who spent less, has more left over. Says Juanita had 3 times as much money left from the shopping trip as Marie. How much money did each sister have at the beginning of the trip? So when I draw the $59 and $153, let me do this first. Let me put Marie's $153 right here. And this is the portion that Marie has left. But now Juanita, who spent more, she has 3 times as much money left as Marie. So I need something up here to indicate that it's 3 times the size of this right here. I'm going to draw the lines in. Those striped compartments need to be the same size because Juanita has as much money left. She has 3 times as much money left as Marie. So this amount right here, which is the money left, should be 3 times the size of this much money here that Marie has left. Those striped or shaded boxes should all be the same size. So this is $59. So I've got, let's suppose I put question mark in there. So $59 plus question mark, plus question mark, plus question mark. That amount has to be the same as $153 plus 1 question mark. So I want to find out with this relationship how much money each of the sisters started out with, since they started out with the same amount. By the way, that's what I'm saying when I put this equal symbol here. I'm saying that all of this money, whether it's the $59 that we know or the money that's left that we know, together with what Marie spends, $153, together what she has left, those two have to be equal. So we know that $59 plus 3 question marks has got to equal $153 plus 1 question mark. So the question is, what do we do with this arithmetic expression to figure out what the question mark is? There's 3 question marks on the left-hand side of this arithmetic expression and 1 question mark on the right-hand side, but they represent amounts of money. So if I were to subtract one question mark from the right-hand side and subtract one question mark from the left-hand side, those quantities are still going to be equal. I've written down what are preliminary steps, and this is probably a good problem for you to finish on your own. You'll notice what I'm getting ready to do is I've indicated that I'm going to subtract a question mark from both sides of the equation. When I get finished doing that, I will have $59 plus two question marks, or 2 times question mark on the left-hand side, and on the right-hand side, I'm just going to have $153. What I want to do now is I want to subtract $59 from both sides, and when I subtract $59 from both sides, it'll clear off the money from the left-hand side, and on the right-hand side, I'll have the difference between $153 and $59, which is what? 41 plus 53 is $94. Okay, so I'm going to have $94. So I'm going to have 2 question marks on the left-hand side and $94 on the right-hand side. And so since 2 question marks is $94, 1 question mark is going to be half of the $94, which I believe is $47. Okay, so this means that Marie has $47 left after the shopping spree. Well, that finishes or allows us to answer the question, because if Marie has $47 in the amount of money she has left, the $47 together with $153 adds up to $200. So both Juanita and Marie have $200 at the start of the shopping spree. Now, you gals out there know that starting a shopping spree with $200 is probably not enough, but for Juanita and Marie, it is. We'd planned to do a 7th problem, but I think we've done enough. We've gone through 6 problems where we've illustrated the processes, procedures, the things that you have to do in solving a word problem. But here's the important thing I want you to remember. When you start out working a word problem or solving a word problem or a challenge problem, the front end, when you are creating your mapping frames or drawing pictures to transfer information in printed form into picture form, that's the most important part, because when you get finished with that task, what hopefully is revealed by your mapping frame, or it might be a series of several mapping frames, what's going to be revealed is what is the target set? What's the set that you want to find the size of? And depending on how that target set came about, did it come about through addition, through multiplication, through subtraction, through division, or maybe several different kinds of arithmetic principles, it will let you know what it is that you have to do to solve this problem. Solving problems aren't necessarily easy, but remember the first step of the 8 best math practices. Your job is to make sense out of the problem, but more importantly is that second part, persevere. Keep going, persevere until you reach the solution. And I hope this has been helpful to you. Thanks.